All right, now that we know how to calculate some measures of center, let's look at their applications in the world around us and take a look at when we should and maybe shouldn't use them. Okay, for our first example here, what I've done is I've taken a sample. You can tell by the graph there were 100 American men in this sample. And I've plotted their LDL, their low density lipid or bad cholesterol levels on the horizontal. So in the left part of the graph, you see below 3.25, and then the next part is 3.25 to 3.75. These are those bad cholesterol readings you can get from your doctor if you get a blood test done. You basically, generally speaking, you want these numbers to be as low as possible. Now, I don't want to talk too much about cholesterol right now. I want to talk about what this graph looks like. So you'll notice it looks kind of similar to some of the graphs we've looked at already in that it's got a peak near the middle and then it kind of falls off to both sides. Now, what does that mean? Well, we can figure out what the mode is in this data by looking at the tallest bar. And that tallest bar looks like it's between 4.75 to 5.25. Taking the midpoint of that, we'd say the most American men in this sample have an LDL of 5. Okay. Median, we can approach the median the exact same way. If we start doing our chops from both sides, chop, 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 we realize pretty quickly that we're going to chop right into that middle bar again. So the median is also about 5. And if we try to use our balance idea to put our tray of cookies balancing on our finger, you're going to notice pretty quickly that finger is going to balance right at 5. That's because the shape of this data is symmetric and its characteristic is unimodal. Now let's go through that. Symmetric means the left side of the graph and the right side of the graph are basically mirror images of each other. Unimodal just means that it's got one high point. And when you have a situation like this, it really doesn't matter if you use the mean or the median or the mode, because they're all the same thing. So in a situation like this, I'd say just grab whatever one's the easiest. And honestly, the mode is going to be the easiest in this point. The challenge lies in when data is not symmetric unimodal. Here's what I mean. Here's an example of that. Now this is some old data. I've updated it in a second, but I wanted to use the old data too, just because I think it's pretty shocking. What I did here, this was back in, looks like 2009, 2010. I grabbed a sample of a few hundred homes in Bend for sale, their sale prices. Now, it's a little bit weird to look at the data. I tried to make it not crowd the horizontal axis too much, but those numbers down there are in hundreds of thousands of dollars. So $100,000, $150,000, or $150,000, $200,000, $250,000. The height of the bar shows how many houses I got in the sample that are between those prices. So for example, the highest bar here, which we call the mode, there are about 200 houses in my sample that had sale prices between $150,000 and $200,000. Looking at the far right bar, there were maybe 15 houses that were between $750,000 and $800,000. So on this data, I was able to calculate back about 10 years ago the basic statistics of this sample. And I'm going to do it first, what's called without outliers. I'm going to come back to that in a second. It's basically just the statistics on what you see right here on this graph. Now, the average of what you see on this graph is about $300,000. So that, if you take a look at where that is on the graph, it's pretty far to the right of where the high point of the curve is. Now that should make sense, because if you use the tray of cookies analogy again, if you put the finger at the high point of the tray, that tail off to the right is going to fall. So you have to move your hand to the right to keep balancing that tray. The median is a little bit left of the average, just because there's, I'm assuming, so many data points on the left side versus the right side. And the mode, we already figured out what the mode was. It's $175,000 because the high point is between $150,000 and $200,000. Look how different those numbers are. In the previous graph we looked at, the mean, median, and mode were all basically the exact same thing. But here, the data is so asymmetric that all the statistics end up being pretty far away from each other. Now, when I say without outliers, what I mean by that, without outliers, there were a lot more houses that were to the right of $800,000. And if I leave them in the sample, these are the numbers I actually get. If I include all of those other expensive houses, the average actually jumps up by 33% to about $400,000. Now, why did the average jump up? Well, again, if you use the cookie analogy, if we're balancing at $300,000 and we add a bunch more cookies way off to the right of this graph, and that'll have the effect of tilting the right side of the tray down, so we're going to have to move our hand over to balance it. Now, we don't have to move it very far graphically. It's only going from 3 to 4. That's because there weren't that many outliers out there, which tells us the ones that were out there were super, super, super expensive. And we'll come back to discussions like that later in this course. We're going to come back to this idea too, the trimmed mean. So when you see a trimmed average, that's that next one down there. What I did in this one was I took out the highest and lowest 5%. So the cheapest 5% of the houses and the most expensive 5%. And then I re-averaged that middle 90%. This is an idea I'd like to revisit later in the course too. But what that has the effect of doing is lowering the average a little bit, because the 5% that were super expensive were ridiculously expensive. And the 5% that were cheap are some of these ones that you see down here at the bottom. So it moves the average back towards the without outliers average of $300,000. The median and the mode stay the same. And this tells us something very important. This is why realtors use medians instead of averages when talking about houses. Because when you have wildly skewed data like this, the median is generally a better idea of where the middle chunk of the data is. We'll come back to that in a second. I figured it was time to update the data, though. This is 10-year-old data. The last time I probably scraped the web for this data. So I went and looked for some newer data. So here's what I came today. Today is February 12th, 2021. And these houses right here represent the exact same range of prices as the graph back here. So 0 up to $800,000. That's what you're seeing here, 0 to $800,000. And I realized something. It's kind of hard to see what's going on. So I decided to bump the price range out a bit more. Now I apologize, this writing gets really small, but the shape of this data here is actually much, much more similar to the shape of this data back here. You've got this hump to the left and then a tail off to the right. Years ago when our son was young, he saw me working on a graph like this and he said, "That's shaped like a Dimetrodon, Dad." Yeah, buddy, that's actually pretty spot on. But what the shape belies is this. This is what's going on right now. The average home price in 2009 was about $300,000. Now, the average home price of the sales, this is the sale prices, sale listings, $800,000. In just about a decade, it jumped up $500,000. What? Oh, but that's the average, right? The average tends to be susceptible to those crazy houses out to the right that are super expensive. You'll notice if you look at the graph up there, it's a little hard to see, but there's a house out there that's between $3.6 million and $3.8 million. And there, trust me, there are more to the right of that. These are the only ones that fit on the screen well. Look at the median though. The median home price in Bend also jumped up by about double, by about 100%. And my sample data that I grabbed here actually falls kind of in line pretty well with what we're seeing in the news right now. And the mode, maybe heartbreakingly the worst, jumped up by more than 100%. So most houses now are in that $500,000 range. Housing in Bend is crazy. And I didn't want to bum you out with this, but I wanted to talk about this kind of data. This kind of data is called skewed. And when you have skewed data, and here's the original graph again, doesn't matter which one we use. When you have skewed data like this, you got to be careful because the average tends to chase the extreme values. In this graph here, the average was higher than the median and the mode. And that's because the average chases the extreme values. So when you have skewed data like this, you probably don't want to use the average. The average is going to be a bit misleading. You're better off using the median or the mode.